didn't happen. It is exactly 20 after 9 o'clock. Welcome back. And I am smiling simply because I have the most gorgeous young lady sitting in studio with me. She is a final year PhD student in astrophysics from Wits University and also a presenter at the Wits Anglo, Anglo American Digital Dome, previously known as the Planetarium. And the lovely young lady is Javeria Makda. Am I saying your name correctly?
Yes.
Welcome to the show. It is wonderful having you here. And of course, there's a specific reason for why you're here, isn't it?
Yeah.
And that is you want young girls to start reaching for the stars. What does that mean?
I want them to know that the sky is literally not the limit. And I want them to pursue careers that traditionally women haven't pursued. And I want them to know that they are just as capable as their male counterparts in trying to pursue specifically STEM careers.
Okay. For listeners who may not be familiar, like myself, with astrophysics, what exactly does an astrophysicist study?
So we look at the universe at large and the mechanisms behind how everything in the universe works. So the underlying physics principles of how galaxies and stars form and move around, and how our universe is getting bigger or might get smaller in the future, and how it formed to this day. So just trying to unravel, as I like to put it, the mysteries of the universe.
Okay, what first sparked your interest in looking up at the stars and wanting to understand the universe?
Funny story. I, until the age of 8, wanted to be a pilot because I thought that is physically the highest level you could go to. And then I found out that humans have been to the moon and that you can travel to space. So I think I was exactly in grade 3, and I decided, you know what, I'm going to be an astronaut and study space and learn everything I can about space. Now, obviously, there isn't a degree to become an astronaut. Anyone can become an astronaut. So once I did get into studying space, my interest in it just got deeper, and my love for just understanding the universe got deeper. And I said, you know what, I want to research this.
So let's talk about the focus of your PhD studies at Wits University, and what are you hoping to discover?
Well, at the moment, I am working on dark matter, which a lot of sci-fi people might be familiar with. But for those that have not come across this term, dark matter is basically a type of matter that we've inferred exists because of its effects on everything around us, but we can't see it with any of our traditional telescopes. So I am hoping to discover signatures of dark matter particles by looking at data.
What would you do with that information? How is it going to serve us as humankind, humans on Earth?
So it provides us with a very sort of awakening knowledge that majority of the matter in the universe is matter that we have not seen yet, and matter that we've never come across or seen with our traditional telescopes. And this actually makes up 95% of all matter that makes up the universe. So to try and figure out what it is and what it's made of would really help us harness its power. And once we truly understand its physics, then we can try and learn how to interact with it as well.
Okay, so when we look at the night sky, are we actually looking into the past? And how does that work?
Yes. So light is the fastest thing that can ever travel. But even the universe is so big that even light cannot reach you in an instant. So when we are looking up at the night sky, we are actually traveling back to the past, because even our closest galaxies are millions of light years away, meaning it takes light millions of years to get to us from there. So when we're seeing an image of a neighboring galaxy, we're actually seeing it as it was millions of years ago, because its present light hasn't reached us yet.
Do you believe there's life on other planets, the moon? And I'm sure that's a question you get all the time.
I do. Okay, so definitely not the moon. I mean, humans have gone there. We plan on getting back there really soon again. So, not on the moon. But I think life in the scientific meaning of bacteria, small particles, those might exist on, frozen oceans and other planets. But in terms of other humans or green little men, no, I don't think so.
Okay. You talked about dark matter just now, but we also hear a lot about black holes, and this seems to fascinate the public. What actually happens when something gets too close to a black hole? Does it kind of get sucked into it and never to be seen again? Is it an endless vacuum type of hole?
So there's a limit called the event horizon. So as long as you are outside the event horizon, you're just going to keep circling a black hole, sort of like you would go around the sun. So anything with a lot of pull and mass and gravity, you tend to just circle around it, just like, again, we don't fall into the sun. And there is a black hole at the center of our galaxy. So our solar system, all the other stars are actually going around it without being pulled in. But the things that cross that specific boundary, known as the event horizon, do get sucked in, but it's not just an instant disappearance. So I don't know if you've ever seen an image of a black hole, but that bright ring that appears around it is actually matter and light getting bent and stretched out. So we call this spaghettification, because things basically get spaghettified or pulled and stretched by this intense gravity before they get sucked in. And the thing is, we don't know what's inside a black hole. We're still studying it, but anything we can even try and send there is going to disappear. And that's why we call it a black hole, because even light cannot escape it.
Okay, so how do scientists, do you look at yourself and do you believe that you're a scientist with once you've completed your PhD? Would you be referred to as a scientist? Would that be the correct terminology?
Yes. So after I've completed my PhD, I would be referred to an astrophysicist
Okay.
specifically. And that is anyone who researches in astrophysics, studies the universe. They're qualified as an astrophysicist.
Something else also that has always fascinated me, but I just couldn't kind of go beyond my own nose, so to speak. How do scientists study objects that are billions of light years away when we obviously can't travel to them?
So light is really helpful in that sense, because we get to infer, okay, if this object is so far away and light took this long, to get to us, it tells us about the history of our universe and how different ones evolved, and everything in the universe is not the same age. So you get to study young stars, old stars, young galaxies, new galaxies. And when you sort of see the progression from one to another, you sort of get to build this story about the universe, in levels. Like, this is how this type of star might have started, and this is how our star might end, because it's similar to another star that we're witnessing ending now. So light helps us build this entire story.
Do you believe in the Big Bang Theory? Is it going to happen? When is it going to happen? Is it kind of millions of light years away from us?
So the Big Bang Theory mainly states about how the universe began. So it began from a singular point or a singularity where all the matter ever was condensed into like one extremely, extremely tiny, dense place and point, and that pressure couldn't hold it any longer, and it all sort of not burst out but expanded out really, really fast. So yes, a lot of evidence does show that the Big Bang happened already 14 billion years ago, because that is how old our visible universe is. So before that, we don't know what happened, because light before that hasn't traveled to us. So the furthest we can look out into the universe is its starting, which is 14 billion years ago.
But there is a possibility that it could happen again.
There's a very high chance that the Big Bang has happened, yes.
And will happen again.
We don't know about that. So there's a few different theories about how the universe might end. So one is that there, just like we had the Big Bang, there might be a big crunch. So, the universe is expanding and getting further, and everything's getting further away. but at some point it might stop and, recollapse back into a singular point. Other people say that things are going to keep expanding until it cools down to a point where the temperature is like absolute zero and nothing moves at all. So that's called the big freeze. And then I forgot, there was like there's three different scenarios of how the universe can end, but we don't call it the Big Bang because Big Bang was just how it started.
Okay. I should imagine there's still major mysteries about the universe that scientists just cannot explain.
Oh, 100%. And I think for me personally, especially as a Muslim scientist, that really helps me strengthen my faith. Like as much as we can try as humans to try and make this physical sense, there has to come a point where even as scientists, we have to take a leap of faith. And there are things that we can never know and see. And I think that's just a common misconception that a lot of scientists are not, very into faith or religious in that sense. And a lot of people are worried, especially when, girls or their kids go into scientific fields like this. But for me, I have found that studying the universe has increased my awe of, Allah and how I feel closer because I'm trying to understand this amazing universe that He's built.
How important are South Africa and institutions such as Wits to the global field of astronomy and astrophysics? Are we kind of on par? Are we way behind?
We're surprisingly quite important, especially in the field of radio astronomy. So in the Karoo, we have something called the Meerkat telescope and the Survey. So those two are collaborating with Australia. They form the Square Kilometre Array, which is basically a giant telescope built out of little arrays, but it covers an area of 1 kilometer, which is massive. And what that allows us to do is take huge patches of the sky and study it at a single time, and take multiple images of the sky every night. So people all over the world use data from South Africa, especially in radio astronomy, to study things like black holes and stars and how galaxies might collide into each other. So South Africa, very important, very forward. I think last year, the year before, we held the International Astronomical Union meeting, which happens every 4 years, which was held in Cape Town. So South Africa is quite forward in that sense. And Wits, being currently the #1 university in Africa, is sort of recognized as at the forefront as a researcher in this topic.
In terms of the advancement in science and technology as a whole, and this might be outside of your field, but are we any closer to perhaps in South Africa, and I should imagine all around the world, to try and generate power, energy, which can then eventually be stored in a certain way and be used when needed most in the winter months, or, things like that? Because I should imagine that is very important as far as science and technology is concerned.
100%, yeah. So I think it's a matter of implementation, but South Africa is geographically located in an ideal spot where we have pretty much a lot of sun throughout the year. Even our winters, it doesn't snow, especially in the cities and stuff. We get a lot of sunlight and hours of sunlight. So solar energy is quite a big one that South Africa can do. But also, if you go towards sort of the mountains in Cape Town and stuff, we get a lot of wind as well. So if we can just harness that wind
energy.
If there was funding going towards this, like we already have dams that make electricity, so if they were regularly maintained and then we had a lot more windmills and funding went into that, and a lot more kids and engineers worked on that, I think that would definitely lower the cost of energy, but also we wouldn't have to rely so much on coal and pollute our environment with it.
The all-important question, artificial intelligence and advanced computing, how does that play a role in astrophysics?
It's actually a massive part of it now. I think only in the recent years has astrophysics become, artificial intelligence has become really prominent. So you'll hear every child, every adult, using different AI models, but scientists have been using it for quite some time. And the reason is we can no longer do the math that is needed by hand because the amount of data we are looking at is ridiculous. And it's not just theoretical stuff that, scientists back then did on the board. So if you're looking at terabytes and months and years of data and going through it by hand, is going to be nearly impossible, and stacks of papers, and you won't remember anything. So to do that quickly, computers and artificial intelligence help us code and come up with processes that will analyze this data for us, leaving us to ask the important questions and look at the results of that data and draw conclusions from it.
So what is the most surprising thing that your research has taught you about the universe? And as a PhD candidate, what are some of the biggest challenges you face in conducting this type of research?
I think
We need to wrap.
I have learned about the universe is that not only is it expanding, but it is expanding at an accelerated rate. So things are moving away from each other, but they're all moving away from each other faster and faster and faster. And I think the second is what I'm studying, dark matter, and that's why I'm so interested about it, is because we know this thing exists. We know it makes up majority of the matter in our universe, but we can't see it. We can only feel it, and see its effects. And to not be able to see something, but know it's there and trying to figure out that mystery just really excites me.
Okay, let's wrap up. I'd love to sit talking with you for the rest of the hour, but unfortunately, time has run out. What would you say to young South Africans who dream of becoming an astrophysicist, but thinks that a career in science is out of reach? That's the one part of the question. And if you're not, apart from NASA, if you're not employed by a university like Wits, what is the field of work, employment look like for an astrophysicist?
So a lot of people who haven't done maybe a PhD, because masters and PhD are those who want to stay in academia. You can still do a degree in astrophysics and undergrad. And a lot of my colleagues who've done that have gone to become data scientists for different tech companies. You can work in finance actually as well. And you can work for a lot of the banks. Banks, insurance companies, they love physicists because we learn problem solving and critical thinking skills. They love the coding and the math skills that come with it. And I think any kid who is interested in a science career, I would just encourage them to keep being curious. Science and physics especially is just about asking questions constantly, not giving up their curiosity. And no matter how difficult the subject of physics and math may seem, if you are curious about it, you keep asking questions, you will eventually get it.
Javeria Makda, it's been an absolute pleasure chatting with you this morning on astrophysics. I've learned a thing or two. Thank you so very much for being here. And once you have done, and you're on your final year of your PhD, once you're done with it, please come in again and chat with us. I'd love to talk to you again.
I'll hopefully be Dr. Makda by then.
Inshallah, inshallah. You go well, and salaam alaikum to you. Thank you indeed for being here.
Thank you for having me.
9:38 exactly, news and views moving along. Please stay with us.